The first thing we're going to learn about is called a cross section. Now, what does a cross section sound like to you? Yeah, good. If I'm talking about taking the cross section of an organ, what am I doing? No. Just lady. I don't think so. It's just lady. If I say I'm taking the cross section of a human body, what am I doing? Looking at it how?
From the front, from the top to the bottom.
So, if I say I'm taking a cross section of a human body, it's like I'm cutting the body in half and just looking at the insides. When I take
like a cross section on like a sandwich.
Right, if you take a cross section of a sandwich, it's like you're cutting it and then looking at the insides. So, what a cross section is, it's a plane, which if you remember from the very, very beginning of geometry, what is a plane? Yeah, it's a flat surface that goes on indefinitely, right? A plane cutting a solid. So what I want you to do is draw a cylinder. Like so. And then I want you to kind of draw a parallelogram. This is kind of hard to draw. A parallelogram kind of looking like it's going through the center of the cylinder with a dotted mini parallelogram. Of the same shape. Yeah, if we say shade inside that dotted, that right there is our cross section. What shape is that cross section? It's a rectangle. So here, the cross section is a rectangle. Right, so any three-dimensional shape that you draw on paper is always going to look a little bit skewed. So this is my cylinder, right? My coffee cup is my cylinder. Yeah. What this is literally doing is taking my coffee cup and cutting it. It's cutting it right in half, and it's asking you what shape is that cut out piece. So if you look at it directly from the front, what shape is the cut? It's a rectangle.
So what you're saying is you would use the same formula?
There's no formula for this. This is all just cognitive. It's the wrong word for that. Yeah, wrong word for that. It's all, you're just logic, you're using logic to piece together what shape you're cutting. So you don't need to draw this next one, but I want to do one more. What shape should I do? Hello?
Send me that spreadsheet.
Oh, yeah. Oh, crap. I wanted to show these guys that spreadsheet. So here I have this shape drawn. I'm going to do, you don't have to draw it. I am going to do some cross sections. So say I cut it like this, what shape does this create? Oh gosh, there are too many lines. There we go. What shape is that? It's a rectangle or a square. A square is a type of rectangle. What about if I cut it like this? Oh, yes, Cayman. Right here, you see that little tiny cutout I did? It's a what? It's a triangle. Well, it's supposed to be. What about if I cut it like that? What shape is this? Oh, it's a trapezoid. Do you get the point of cross sections?
So are we looking at like the dotted spot that's
The dotted. That's the actual cutting part. A cross section is like if I took a saw and cut the shape. It's asking what shape does the saw create? Yes. All right. So that's it for cross sections. Next we have rotations. Yeah, but with solids instead of just 2D. So this is the next thing. This is the second thing we're learning. Rotation. Shh. A rotation is created by rotating a shape around. Shh. I'm shushing the people in the hall. An axis. So if I were to draw a line, and I'm calling that my axis of rotation, and then I were to draw a triangle on the axis of rotation. If I tell you to rotate that triangle around that axis, what shape would I end up with? So here, this ruler I'm holding is my axis, and here's my triangle. I have my triangle on the axis. If I were to rotate this triangle around the axis, and the triangle were to leave like a trail of solid, so anywhere that the triangle touches remains solid, what shape am I creating here? Oh, a cone, right? Do you see it?
yeah.
Jorge, do you see it? What shape am I creating? What shape am I creating? You're right, a cone. It's like how I think about it is there are 3 points on this triangle, right? A point here, a point here, and a point here. Well, the bottom 2 points are on the line, so are they going to move at all? No, but this top point is going to rotate around the shape, creating a circle for a base. And then if I just connect that circle to the other dot, what shape is that?
That's a whole cone.
It's a cone. It's a cone. A triangle. Oh, I should have done this in a different color, shouldn't I have? Oh, it's going to crash. Yeah. A triangle rotated around an axis forms a cone. So last thing we're learning about is dimensional change. Now, dimensional change is when you change the dimension on a solid and then are then asked to find the new volume on that new shape. Now, how many dimensions does a solid have? 3 dimensions. Good. So either they can change all 3 dimensions, they can change 1 dimension, or they can change 2. It's literally taking the dimensions and changing them, changing their size. So the best way to do this is to do an example with you. Find how dimensional, I thought so.
Is it T-I-O-N-A?
No.
Dimensional.
Yeah, it's just a weird word.
Yeah, it says I did it right. Okay. Find how many times larger a prism is when the dimensions are multiplied by 3. So your immediate reaction here is probably, oh, it's 3 times larger. But this is not true. How many dimensions does a prism have? 3 dimensions. So it's a 3-dimensional shape, meaning that we are going to be changing all 3 dimensions. How much are we increasing those dimensions by? 3. So in each one of those slots that I just drew, you need to put a 3.
Could you also, since you know it's 3D shape, could you also just do 3 times 3? Or no, that wouldn't work because that's 3 times 3.
So it's 3 dimensions being increased by 3 times. So what you're now going to do with those numbers that we just wrote in there? Oh, actually, I want to label each one of these steps. So if I only put 1 slot, that means that my shape only had 1 dimension. 2 slots means it only has 2 dimensions, but 3 means it has 3 dimensions. And then they each were increased by 3. So now I'm going to multiply each one of these. What is 3 times 3 times 3? 27. So this shape is 27 times larger. Fairly simple, right? And then, of course, there will also be problems like if I double the length on a prism, what will the new volume be? All you have to do there is literally double the length on the volume and then find the new volume. Any questions on this?